All right, let's look at the study guide for momentum. You guys have your test coming up here soon. This first video is going to take care of this table. Let's do one at a time. So we know that momentum is a 3-variable equation that we can use our magic triangle on. So mass times velocity is equal to momentum. If you need to go ahead and label all of those, go ahead and do that. So this is momentum, velocity, and of course mass. And we know that momentum is mass in motion. Then with all of those, you can go ahead and rearrange them. So P is equal to M times V, M is equal to P over V, and V is equal to P over M. And you guys know how those magic triangles work. So this part of it, not absolutely necessary, but if you get anxious during exams, I would highly recommend you putting those versions of the equation in your book. All right, let's look at the next one. The next one is momentum. I'm just going to go over the equation. So it's delta P is equal to M delta V because it's your velocity that's changing. Let's put units here. Okay, so it's kilogram meter per second or Newton seconds. So we can use either one. Typically, kilogram meter per second is our typical. All right, so delta P equals M delta V. We can say P2 minus P1 is equal to M times V2 minus V1. Again, you can take that equation and then solve for whatever you want, right? So if I'm, for example, solving for P2, that would be M times V2 minus V1 and then plus P1. So if you need to go ahead and solve for each of those, and if you have any questions, feel free to ask and I'm happy to check your work. Okay, impulse. This is talking about, so we know we have a change in momentum, right? So when things stop or brakes get slammed on or there's a hit of some sort or a crash, there's a change in momentum. But impulse tells us our force to time ratio. So force is a vector, velocity is a vector, so those can have a plus or minus. So if you're slamming on your brakes, that's going to be a negative change in velocity. But if you're slamming on your brakes, then your force has to be going opposite your direction of motion, so that would also be negative. Your time and your mass are both going to be positive because they are scalar quantities. We're not time traveling in this class and we're not losing any mass. So those are the pieces there. And again, you can solve for the different variants of this. So if you're solving for force, right, that's going to be M delta V over delta T. If I'm solving for my change in time, that's going to equal to M delta V over F. If I'm searching for my change in velocity, that's equal to F delta T over delta V. And of course, my mass would be F delta T over, I just made an error there. Sorry, I was going too fast. This would be mass. And then this would be change in velocity. Okay, so again, these things, not crazy important, but if you get test anxiety, a great way to kind of rewrite them. So if you know what you're solving for and you have all your variables listed out, it's a real easy thing to take care of. All right, now we're looking at types of collisions. This is collide and stick together, or an explosion, right? And we talked about it not being a combustible explosion. We have two ways we can do it. So we'll do the first one here and we'll do the second one down here. So if they're colliding and sticking together, you have object A times its initial velocity plus object B times its initial velocity are going to collide together. So both masses end up joining. and you have a final velocity. So that would be your equation for a perfectly inelastic collision. An example of that might be a marshmallow and a graham cracker are heading towards each other and they collide, and they continue to move after they collide because the marshmallow is sticky. That would be an example of this type of equation. Then an explosion, like a kid on a skateboard, surfboard, whatever. So an explosion means that you're starting out together. So your mass of object A and your mass of your object B times your initial velocity. And then from there, you've got M A V2A plus M B V2B. Okay? Let's look at inelastic collisions. This is, if not elastic or perfectly inelastic. So if it's not one of the other two, it's this one. This is just the general conservation of momentum equation. So mass of A times V1 of A plus mass of B, V1 of B is going to equal mass of A, V2 of A plus mass of B, V2 of B. So you're given pretty much everything except one variable. So I don't know that you necessarily want to solve this out for all of them, because a lot of times, like let's say your second object is at rest, then that whole thing would go to 0. So you never know kind of what's happening. So I wouldn't put too many. I would practice manipulating your equation. And then elastic collisions. We've got two things going on, because we know that energy, meaning kinetic energy, and momentum are conserved. Okay, so we have this equation that we've already written. We're going to copy that, and I'm going to put that right here, see if I can paste it. Will it let me? Nope. No, it's not going to let me paste it. All right, let's go ahead and write these out. So it's the same as the other one, MA V1A plus MB V2B, 1B, is equal to MA V2A plus MB V2B. And you definitely want to have that in your book. And then the second equation, so this is the first equation, your second equation is your kinetic energy. So that'd be 1/2 MA V1A squared plus 1/2 MB V1B squared equals 1/2 MA V2A squared plus 1/2 MB V2B squared. All right, so both of those equations are true. The other thing about elastic collisions is if it has the same mass, right, same mass, then what you can do is swap velocities. Okay? All right, that is our chart with pretty much everything that you need for the top of the thing, and then we will go on and do problems 1 through 4 in our next one.